Hello students, today we'll start Chapter 5.1B, Derivative of a Function. So let's look at what we have learned in 5.1A. In 5.1A we learned the slope of tangent to the curve y equal to fx as x equal to a is actually equals to, we can write it as f pi bracket a, and we can also write as dy dx when x equals to a. And this is the function or the limit of the function. So let's look at what is the derivative. So just try to imagine, in section 5.1a, this value a is a specific number, right? So you just imagine a can be any number, and then now we are going to replace the value a by an independent variable x. Okay, so the limit will becomes this one. Okay, so this limit is different from that before because this is a general run, because x is independent variable, it can be any numbers, right? So this is we have specific name for it, which is called the derivatives of the function. Okay, with respect to x, because now it is the independent variable is x. So how to denote it? Okay, it's just like what we have learned in 5.1a. So it can be denoted by, again, we have dy dx, but this time we don't have x equal to a because x, this is a general, so we can just write dy dx. Okay, or because y equal to fx, right? So we can also write d fx over dx. Okay, and also we can still write f pi, not a this time, is x. Okay, or we can write y pi. So these all are the notations, of the derivatives. So actually, what is differentiation? You may we know this term, right? So actually, differentiation is the process or the method, of finding the derivatives. Okay, so this is just like I try to introduce some terms to you. So now, here I would also like to give you two notes. Two notes. First is if the limit of a function, the limit means this is not referred to the derivative, it's just like the limit itself. The limit of y to the fx at the value x is not exist, then you have the derivative is not exist too. It does not exist. And also the second one, the derivative of y equal to fx at x equal to a, if it is exists, then this function is said to be differentiable. differentiable, it means the derivative is exists. Okay, so now let's go to two examples. I would like to show you some important skills, okay, in finding the derivatives. Now let's look at A. dy dx, okay, from first principle. First principle is one of the method, okay, so you may just treat this as differentiation as well. So dy dx, okay, from what we have learned, okay, it is now equals to limit delta x equals tends to 0, and then now the function x to the power 3. So you can also let fx equal to x to the power 3 as what we have done before, but actually you can also save that step, so by writing it directly. So now this is power 3 and then x to the power 3 and then over delta x. So we learned in binomial theorem we can expand this, okay, binomial, okay, using the binomial theorem. So we get this. Okay, so finally we get this. Sorry, here I have a typo. It should be plus delta x to the power 3. So finally we get 3x squared. So let's do part B. Okay, for this one, again we have dy dx. We got the same. This is x plus delta x plus 1 this time, minus x plus 1 over delta x. Okay, so for the numerator we just try to do some simplifications. So x plus 1 minus x plus delta x plus 1 over x plus delta x plus 1, x plus 1, and also the delta x here. So after some simplification, you get negative 1 over this. Remember before you remove the delta x, you need to keep this limit, okay? So when you want to just you put the delta x equal to 0, then you can just erase this this limit delta x tends to 0, this notation, like what I did here. Okay, finish. And then now we go to example 5.3. I would also like to show you this. A is just what we did as before. So we try to find the derivative of this with respect to x from the first principle again. So dy dx, we will limit delta x tends to 0. So here we get 5x plus delta x minus 1 minus 5x minus 1 over delta x. Okay, actually I think you should know what we are going to do is to multiply the conjugate, right? We actually practice this a lot of time. Okay, so for the numerator, it becomes this, and then minus 5x plus 1. Here we keep this 5x plus 5 delta x minus 1, 5x minus 1. So finally we get 5 over plus. Okay, and then delta x tends to 0. So finally we get this. Okay, so B is extremely easy if you get A correct. So B, the slope of the tangent to the curve at x equal to 1. So the required slope will be equal to dy dx, where x equal to 1. Just simply like this. And finally we get 2 square root 4, so which is 5 over 4. Okay, so actually in the last quiz I found that some of you are not very good in this kind of calculation, so please remember do more practices, and you can leave me messages. Okay, I will reply you. Okay, how to do the questions. So see you.